What's up, Covalence friends? Today we're going to be creating a basic WebSocket server. We are going to be using an npm package called WS, and I prefer it to something like Socket.io. I go into those reasons why in the video, so we're just going to get right into it. Let's go. All right, so we're going to start off with our Express template. The link to this repo is actually in the description below, but you can use pretty much any basic Express template. And we're going to start off with our index.ts, which is where we actually instantiate our Express app, and then we actually create the server here with this listen function. And so if you actually see, this listen function does return a type server. So we want to actually grab that server because we're going to need it. So let's just say const s equals server, or const s equals app.listen, which is our server. And let's pull up a terminal. And I've actually already npm installed the dependencies, so we need to install a few more. We're going to install we're going to save first, and then we're going to install a dependency called WS, which is our WebSocket package. And we're also going to install type since we're using TypeScript. So at type/WS, and we'll go ahead and install those. And perfect, that was nice and quick. And so what we're going to do next is we're going to actually instantiate that server. So we can actually import up here, we can import a type called WebSocket server, and IntelliSense picks that up pretty well. And we'll actually also import a type called WebSocket. And we're going to need this WebSocket a little bit later. We're not going to need it for the server per se, but we're going to need it for some of the business logic. So let's go ahead and first create our WebSocket server. So we can say const, let's call it WSS for WebSocket server equals, we're going to new it up, so WebSocket server. And we're going to pass in some options, and the option that we're going to use is called no server. And basically every WebSocket server, every WebSocket server has to be tied to an HTTP server. And so we could pass in this S as the server, but if we do that, then it's not my cup of tea. I actually like to prefer to do all of my upgrading myself. And the reason for that is that it allows for an actual important step where you can do your own authentication and things like that. And so I'm going to go ahead and do this because this is typically in production. This is what I'll use as opposed to just allowing the library to take care of everything and automatically upgrade the request. And so I'm going to want to manually upgrade. And I'll show you what I mean by that in a second. But basically, this no server also allows us to instantiate multiple WebSocket servers on the same HTTP client, which is also really nice. And so you can do it your own way. If you want to pass in server, I think there's an actual thing here that you can just pass in server there, but we're going to stick with no server true, and we're going to upgrade manually. So the way that we want to actually upgrade manually, and by the way, just a side note, the reason we're using WS instead of Socket.io is for a multitude of reasons, but I prefer WS over Socket.io mainly because it is smaller, faster, a little bit more reliable in my opinion, less memory leaks, and I just prefer the flexibility. And I just honestly, Socket.io is just a little bit too bloated for me, and I don't think it scales very well. So I feel like this is just all you need, and it does everything more or less that you could desire from a WebSocket library. And also I think it plays a little bit better in terms of like actually being allowed to scale out, scale up, that kind of thing. And so just for a side note, when we're actually doing this, we need to make sure that we understand how this is working. And in my particular case, like this, using something like a basic Express server like this is perfect because we want some basic API capabilities, but more or less you really want to keep the server clean and pretty much devoted as a WebSocket server. At least that's my recommendation. If it's a passion project or just like a little tiny project, for sure, go ahead and mix your API with your WebSocket server. But in my opinion, if it's anything in production that you're going to be using and scaling out to a multitude of people, you're going to want to keep your WebSocket server separate from your API, but still have some minor API capabilities. For instance, like we'll get into this a little bit later, but there's some cases where you may want to have a few API routes that you're exposing. And so this works really well. We still have our API here. If we go into our index, you can see that we're still instantiating body parser with or this JSON body parser, and we still have our route for our API. And so we still can have API routes. And so this is kind of the perfect setup that I would say for a WebSocket server. In terms of scaling out, you got to remember that Node apps in particular, a lot of times you want to run on a flexible environment. But with WebSocket servers, if you have multiple instances, people are going to be connecting to a single instance of that server. And so if Bob is texting Sally over a messaging app, and or Sally and let's just say Sam, and Sally and Sam connect to two separate socket servers, right? And then Sally texts the group. Sam is never going to actually get that message because whichever one Bob's on, he's only going to talk to that one person, right? So if you have two instances, it's never going to actually work. So you actually need a third layer that you can use, kind of like a pub sub layer that'll actually allow the servers to talk to one another too. So again, a lot of complications from scaling out. I know this is a basic getting started video, but it's still something that you want to consider and know about when you're actually dealing with your WebSocket server. So again, I'm sorry for the little aside, but those are some seriously important notes, especially when we're talking about a Node.js environment. So anyway, back to the regularly scheduled programming. All right, WebSocket server created, right? So now what we're going to do is we're going to manually upgrade this thing. So what we can say is s.on, and it's on upgrade. And basically this upgrade function more or less fires when a request is being turned into a socket more. So it's basically when a request is more than just a request, it is actually a socket request, right? And so this is actually going to get request socket and head, and then we can actually do something like an error function here. So let's just say for instance case, we want to actually create two functions up here. We can say function, we can say on socket error, and let's just say this would be like a pre error. So this could be on socket pre error. Let's just say E is of type error. And for this, we're just going to console log. But you may want to actually do, some logic in here where we're actually doing something when there is a socket error. But we also want to have a post error as well. And I'll show you why we have two. It helps with your error handling. It makes it a little bit more finite or a little bit more granular in terms of like actually knowing what's happening in your application. So now that we have s.on upgrade, we can say that this socket.on, and we can say error. We're going to do the on socket pre-error, all right? Because this is actually before we've officially upgraded and emitted this connection into our WebSocket server, right? So typically this part right here is where I would perform any type of auth. So realistically, you're kind of limited to cookie auth in this particular case. So if you were connecting from a mobile app, this is where the API capabilities would come in handy, because if you're connecting from a mobile app, what you'd probably do is send an API request with some sort of bearer auth token or JWT or something to actually authorize the person, send back some sort of secret, and then pass the secret up with your connection, or as maybe even the first message of your connection to authorize that user. And it wouldn't typically happen during the upgrade, unfortunately. So there's not really a great way, or what you could do is you could actually pass it through on the path itself. And so you could actually pass up a path and check it on the request. And if that path contains the token, that's where you would perform that authorization right here, right? And so that a lot of times you could even pass up your token as part of the initial request. So basically you could perform off that way, or you could perform off here with like a cookie parser, and you could parse the cookies and determine whether or not it has an access token. So there's a multitude of different ways you could do this, but I recommend that this is typically where you perform the auth before the upgrade, so you don't actually pass this on to your WebSocket server, let's just say. So again, my recommendation from the web, use cookies. From a mobile app, I would actually pass the auth token up in the route. And if you're using like rooms or routes or that kind of thing where you're trying to segregate things a little bit more, just create a path, define your path, and then make sure you stick to that syntax, and you can always pass up that token somehow, right? And so just make sure that you parse that token and make sure that that's not actually authorized user. And then right here is basically, where you'd say let's just say if, let's just say if, let's use request.headers. So let's use request.headers here. And for whatever, we'll say no auth. So we're just using this as basically something that's saying, you know, if the auth is bad, right? Bad auth. Yeah, let's just say bad auth. How about that? Request to headers bad auth, right? Then we would actually do something like, let's just say, you know, socket.write. And you could do, you know, some HTTP error code. Let's just say, you know, 1.1, 401 unauthorized, right? And then, all right, let's see. Whoa, /r/n/r/n, right? All right, so anyway, you can do something like this where you write to the socket and then you just destroy it. So destroy the socket, good to go, and then just return, right? So you don't have to worry about that. You just destroy the socket, nobody got in, you're good to go. Now, if it does happen to be good auth and you're ready to keep going, then you can actually call something called handle upgrade. And this is on the WebSocket server itself. So you're going to pass in the 3 arguments that came into your upgrade here, the request socket head. So we're going to pass in request socket head. And then our last one is a callback where we get our actual WebSocket itself, excuse me. So we now have our WebSocket here. It's been upgraded into our WebSocket server. And right now we can actually call a socket.removeListener for this error. And now we can say, we can remove the pre-error function and we're going to emit a connection event. And we're going to pass in the WebSocket and the request here, right? So we're emitting the connection event. And so what do we have to do? We have to actually listen for this connection event now. All right. And so that's where after our s.on, we are going to have a function wss.on, and this is on our connection. So we get exactly what was passed in. We get our WebSocket and our request. And in here, we can actually now redefine an error function, and we can say onSocket post error. So now we know that the post error is actually when the WebSocket server is handling it, and the pre-error is when our HTTP server is handling it. And so now we know that, like, if we're in this function, we've gotten all the way to the WebSocket server and we have a problem with our WebSocket server, but if we're in the pre-error, we're actually still in the HTTP handler. So that's an important distinction. That's why I like to use 2 different functions here. But again, it's up to you. If you just want one error to know that it failed, you're also good to go there too. So, all right, let's keep going. ws.on, so we want to make sure that the WebSocket itself is listening for the message event, and that's going to be a message and an is binary Boolean. So if we just look at this real quick, we can see that the message itself is raw data, and the is binary is just a Boolean value about whether or not that data is binary. So it's good to know. We can do a wss.clients, right? So this is all of the connected clients, .for each, and it's going to be a function in here. So for each of the clients, we're going to loop through and we're going to get each client itself, and we can check if client.readyState equals. This is where that WebSocket import came in. If it's open, we want to client.send the data itself, and we can actually set a value here whether or not it's binary. So all right, and this clients here actually includes the client itself that is sending the message. So that is an important distinction. Right now, if we sent up a message, if it was me sending up a message to the server, it would then get it and it would send the message back to me, which again, it could be what you want to do. It might not be what you want to do, right? If you wanted to check if it was the actual client, what you could do is you could actually check if WS, if WS does not equal client, and then you only send. So this would actually send it to everything except the person sending the message. So again, it depends on what you're looking for. There might be certain cases or certain routes that you're using where you actually only want to send that. But again, play with it and see which use case you need it for. And if that's the case, you might need to send it to yourself. You might need to send it to everybody. Now, I think a lot of messaging apps, like for instance, WhatsApp in particular, they kind of have like little check boxes in there, right? And a lot of times they'll automatically post your message to the UI. but then they'll put a check mark when I think they receive the message back. So I think a lot of people do include themselves in the message reply back, but then they probably have an actual, like, this can be all, JSON data with some sort of message ID, and they get the message ID back, and if they've already put it in the UI, they just put that little check mark in there saying that it's been received and everybody's received it, right? There might be a second check mark for when people read it, that kind of thing. But messaging apps have all sorts of different little tidbits in there that are supposed to be used for increasing read rate and everything like that. So decreasing errors, increasing reliability, all that, right? So the last thing that would be an important one to kind of put in here would be the close function, right? And this is when the socket is closed, so you can actually perform some cleanup here. But we just might log connection closed for now. But just so you know, this function will fire when this socket connection is closed, right? And a big kind of message, or a big issue with WebSockets in general, are kind of stale connections. And so there's additional logic that you can put in here. I'll probably do a future video on handling stale connections and whatnot, because sometimes the client will drop without the server knowing, sometimes the server will drop without the client knowing, right? And so there's different ways. Really the best way to do it is with kind of like a separate kind of heartbeat ping where you're pinging, and if you're not getting any type of response back or anything like that, then you actually need to kind of close that connection manually. But again, we'll kind of handle that in a totally different video down the road. And yeah, we'll get to that. We'll get to that later for sure. So again, this is pretty much the basic bare bones of a WebSocket server. So it's extremely simple, and it really comes down to just one big for loop, which I've always kind of found a little bit ironic. So, again, the WebSocket server seems daunting at first, but it's actually extremely easy to create and extremely easy to implement, right? Now, making it good and making it able to scale, that's where it gets complicated. So the architecture is really the hard part about it. And, the code itself is pretty bare bones. So, again, let's kind of keep going from here, right? And so let's go to our public side now. And in our public app, we're going to start with the actual index.html here. So let's go ahead and just delete this hello world. We're not going to need that. But we are going to kind of start, well, I guess we could have an H1 in there. Why not? We'll just say, test. We can change this to be, WebSockets. And underneath that, let's do a button. Inside this button, let's do like an open connection button. So let's use IDs. I'm not a big fan of IDs, so sorry guys, but let's just do IDs. We'll do get element by ID. We're only gonna have one of these buttons. This is just a test. But let's do a second one that's for closing, WS close, close connection. And then let's do a little input block. So div.input block, and inside this input block, we're going to have an input. It's gonna be type text, and again, ID, and then also a button for sending. So button, let's do send message, and let's see, we'll do WS send. All right, and the last thing that we need is underneath the input block. Let's do a little pre. I never really use pre's, but again, we'll give it an ID. Let's just say it's going to be messages, and this is where we're going to actually put all the messages that we get, right? All right, so this is pretty much all we need for the index.html. It's going to be quick and easy. I'm not going to do anything too complicated. I'm just going to append text to this pre here. And yeah, we're not going to do any type of like text message styling, but you can if you want. I encourage you to kind of expand upon what we're doing here and make it look really cool and add a bunch of CSS and whatnot. But for our CSS, let's actually go into styles.css here. We'll leave that H1 green. Why not? Be a little bit different. Let's do the input block class, and let's just say, let's give it a little bit of margin so we can space it out a little bit. And then finally, just messages. Let's give it a height. Let's just say 20 ems. Let's give it some overflow auto so that it'll actually just let's see, scroll if we need it to. We can kind of scroll it down as well, so it'll keep scrolling down to the bottom every time. And then let's say margin top. Let's also do a little margin there too. So 1em margin. And then finally, that'll be good for the CSS. We can pull up our JavaScript now, and we can remove this express rocks. All right, so let's go ahead and grab all of our elements here. So messages equals, it's an HTML element, and we can do document.get element by ID, right? Messages, all right, const WS open equals HTML element. It's a button element, right? Button element. Oh, not BR, button. There we go. And we can more or less just kind of copy this. And it's going to be WS open, right? And then we're going to have the same thing for close. All right, WS close. And then we have our send button. So WS send, and that's going to just be there. And then finally we have our input, which is going to be an input, HTML input element. And we'll change this, and then finally, here we go. A lot of copying and pasting, right? So let's create a function here, function show message, and we'll say message string. And in here, let's just say messages dot text content, and we'll say plus equals, we'll put a new line and then the message itself, right? So a new line and then that, and then we'll say messages dot scroll top equals messages dot scroll height. All right, and that should scroll it down to the bottom there. Let's see, might not be an optional property, so let's see if we just remove that. All right, so we'll just remove that. We can also just say, you know, if not messages, return. All right, that way we won't get an error there. All right, so we have our show message function now, right? So now we can actually call that. Now, the only other thing that we might need, let's go to the top here. Let's just say let WS equals, and it's going to be of type WebSocket. All right. And we are going to do our WS open dot add event listener, and it's going to be on click. So when we click that button, we're actually going to open it. Now, in your particular app, you might have it when it navigates to a certain page, it might automatically connect, right? Usually you wouldn't actually click a button to connect to a WebSocket. I mean, it might be after login, but we're going to manually show you the difference, because if you're not connected, you're obviously not going to receive messages, right? So I want to basically show the differences here, but you can say that when you want to open the connection, you can actually first check if the connection exists, and if it does, you actually want to close it first, right? So we want to close that connection first, and then we're going to say, because we don't want to just leave that WebSocket connection open if it already exists, and we're going to create a new WebSocket, and it's going to be the protocol WS, right? Now, if you had encryption, it would be WSS, but in our case, we're just going to use WS, and it's going to be localhost, and then 3000 is the port, so we're going to leave it as localhost 3000, and then we're going to say ws.addEventListener, and let's first define our error function, right? All right, so we can just kind of show message. We'll just do this show message for pretty much everything, and we'll say WebSocket error, right? Let's do lowercase. I think it looks a little bit better. All right, show message WebSocket error, right? And we can pretty much copy this, and we're going to say open, and it'll be WebSocket connection established. And finally, on close, well, not finally, I guess, we're gonna have our open or close, and then we have our message still, right? So we're say WebSocket connection closed, and then finally we have our message, right? So message is the last one. So it's on message. We actually want to show the message itself, right? So we can say in here, it'll be an argument, and it'll be, you know, message event, and it'll be of type string. Now you might have an object in here, right? If you have a user ID, things like that in there, most of the time you will have an object. It's not gonna just be a string. You'll have an object itself. You might have to parse the object, that kind of thing. But in this particular case, we're just going to do a string itself. And then, well, I guess technically it might just be a string and you need to parse it into an object. It's up to you. There's different ways to kind of define this from a TypeScript standpoint, but again, by default, the string itself is going to be the type of the data on here. So MSG, we can kind of look at this object real quick, but more or less, let's use the types. We'll say received message, and it's going to MSG dot. Now, you can kind of see that it looks similar to an event, right? Like a DOM event in a way. It has bubbling, it has cancelable, it has is trusted, origin, things like that, right? So you can stop propagation, all sorts of fun stuff, timestamp. So it is pretty similar to a DOM event, but what we need is this data here, and that's the data itself that's being sent. So we're gonna grab that data, it's going to be a string, and we are going to now receive the data itself, and we're going to show it as received data, right? So again, that was the WebSocket open. We're creating the WebSocket, and we're instantiating all of the listeners when the WebSocket is established. So if that was on page load, then you would do all of this on page load, right? Now, we're also going to create a close event, right? So we're gonna have that close button, so it's add event listener. Let's click, and we're basically gonna do the exact same thing as what was in the open, except that's all we're going to do. So we could actually have this function separate, if we really wanted to optimize, usability here, we'd have a separate function here. So let's just say function close connection, and it would just be, this code right here, and we could call close connection. Obviously, most of you guys know how to write functions, so this is kind of redundant, but we'll just put that in there and make it a little bit cleaner. All right, so now we have our close connection calling. So we close connection in the open, and we also close connection on the close, right? All right, so the last thing that we have to do is actually the send, right? So we can say ws send add event listener, and that's going to be click. And similar to the other two, we're just using our event handler here. And we can first check if WS exists, and if it doesn't, we can show message no WebSocket connection, and we'll just return. Otherwise, we're going to actually grab the WS input dot value, all right, and we're going to check if not val. We're just going to return because we do not need to. We could do this first, actually. You could just, you don't even need to check, if, for instance, if WS doesn't exist, right? So you can say else if not WS, then you want to show that, right? So only if val exists do we even check, because otherwise it's not even a big deal because we're not doing anything, right? So I prefer checking this first. And then if WS does exist, if our socket is connected, then we want to do ws.send, and we're going to just send val, which is our input value. And then we're going to show message after that, and we're going to say sent, and we're going to pass in val here. So we're going to actually see when we send the value, and then we're going to see when we receive the value as well, which is going to be an important distinction, obviously, but it will make a little bit more sense when we open up more than one connection, right? All right, so I think that's pretty much everything. I don't believe I messed anything up, but we're probably going to find out pretty quick. Let's go ahead and run this thing. So npm run dev. All right, listening on port 3000. Let's go ahead and pop open localhost 3000. All right, so we can pull open the, I don't think we're gonna need anything really in here, but let's go ahead and just have it open just in case we see any errors or anything like that. But you can see that if we send the message, nothing happens. If we try and send a message, then we don't actually get that. No WebSocket connection is put down here. But it would be nice to actually, maybe if we do send it, let's do one more thing. Let's go ahead and, forgot a semicolon. We're going to say ws input dot value equals empty string, right? So we want to clear that value. All right, get a little automatic recompile, and we'll pop this back open. And again, we can't send the message. Closing the connection doesn't do anything, but we can open the connection. We now have a web connection established. WebSocket connection is established. We can send not tset, let's just send test. All right, sent test, we received test. So it went up to the server, went through the upgrade process, and then back to us, right? So it went through the clients. We only have one client at the moment, and it sent us the message test. Now, if we wanted to open up a second one, all right, let's go ahead and pop this out, and we're going to go to localhost 3000 again, and let's shrink this up. Let's shrink it up to about half size. We're gonna kind of put it over here. Let's make it a little bit bigger. There we go. All right, so now we have two instances open. We only have one connection still, right? So for instance, if we sent another message, test2, right? We pulled this back up. You can see nothing actually happened here. But if we open the connection and we send test3, you can actually now see that we received the message test3, all right? And so we don't actually have to send a message to receive a message. Once the connection is open, we're receiving. Now, if we wanted to go ahead and send, ping, we get ping over here, and pong, we get pong back, right? Now, if we close a connection, if we go ahead and say, all right, we're done over here, let's go ahead, well, let's close the connection over here, right? So we close the WebSocket connection. Now, if we sang something else here, let's just say, song. We can see that we sent song, we received song, but this connection is closed. So we didn't actually get anything over here. All right, so that client is now done, and we're not actually ever going to be receiving data anymore, right? So again, you can see that we can open up as many of these as we want, and it's going to actually send them to all of them, right? So let's go ahead and do that just for fun. Let's do one more, localhost 3000, pop this out. And we're going to go ahead, open this connection, all right? Then we're going to pull these up, and we're going to say, hello world, send message. Oh, we got to open this connection first. Send message. And you see receive message, hello world, receive message, hello world, receive message, hello world. So we have our WebSockets communicating to all instances. We can scale this out probably to about 10,000 before it starts giving us really any issues. So again, I love the WS NPM package. Socket.io is another option that you could look at, but I prefer using this one because it's cleaner, and honestly, it's everything you need. So hope you enjoyed, and we'll see you back here soon. All right, so I hope you guys enjoyed that, and I hope it was easy enough to understand. There's definitely things that you can kind of take and run with as far as WebSockets go, because again, this was just a basic video setting up a very simple server. But again, we're probably going to have some follow-up videos that kind of go a little bit more in depth in some of the topics that we discussed during the video itself. So if you have any questions or suggestions, feel free to drop them in the comments below. Make sure you subscribe, and also check out our merch store, check out our courses online, and honestly, have fun with development. Come back, see us soon, and good luck.